Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 13.4, Problem 5. This is Section 13.4, Problem number 5. It says, draw the graph of the following function. Be sure to label the x and y coordinates of any critical points. And the function for this one is f of x equals x squared plus 4x plus 10. So to get a graph of this function, it's a 7-step process. Step 1 is take the first derivative. So f prime of x, the x squared gives us a 2x to the first. Again, the exponent of 2 comes down times the number in front, which isn't written but understood to be 1. So 2 times 1, there's the 2. X to 1 less power, the second power drops down to a first power. Then next piece, the 4x, the derivative is just 4. Again, when you take the derivative of something to the first power, the derivative is just the number in front, or what you would call the coefficient, positive 4. The 10 has no x with it, so its derivative is 0. So f prime of x is 2x plus 4. That's step 1. Step 2, set the first derivative equal to 0. 2x plus 4 equals 0. Step 3, solve for x. So to solve for x, I'm going to go 2x equals minus 4. That 4 will come to the right-hand side, change from a positive 4 to a negative 4. Divide out the 2 in front of the x. X is minus 4 over 2, which reduces to negative 2. So what that's saying is I have a critical point, or a point with a horizontal tangent line with an x coordinate of negative 2. So if I'm back 2, I'm going to have that critical point, but I need to find the height. Back 2, up or down, how much? So take my x is 2 for my answer. The fourth step is put it back into f of x and find the y that goes with this x of minus 2. So f of minus 2 is x squared is minus 2 squared, plus 4 times x is 4 times minus 2 plus 10. Do the math. Negative 2 second power, negative 2 times negative 2 is positive 4. 4 times negative 2 will be minus 8. You have a plus 10 at the end. So if I combine positive 4, positive 10, I have positive 14. Positive 14 and negative 8 is going to be positive 6. So the y coordinate that goes with that is minus 6. So my critical point has an x value of negative 2, a y coordinate of positive 6. So the next step, step 5, is plot that on the graph. So if I go to my graph, I go back 2 and up 6. There's the point, negative 2 up 6. So that represents either a maximum or a minimum. Either the graph is going to come down, 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 flatten out at negative 2 up 6 and go back up, or it's going to come up, 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 flatten out, and go back down. So to find out which one of those two it is, I'm going to put in an x value just a little to the left and a little to the right of my critical point and see if it's up a little higher or lower than where my tangent line flattens out. So my critical point has an x value of negative 2. Let's try negative 3 and negative 1. So first, negative 3, plug it into f of x. F of negative 3 is x squared will be negative 3 squared, plus 4 times x is 4 times negative 3, plus 10. Negative 3 squared is positive 9, right? Negative 3 times negative 3 is positive 9. 4 times negative 3 is negative 12. And then plus 10 on the end. If I combine my positives, positive 9, positive 10 is positive 19. Positive 19 and negative 12, I'm going to have positive 7. So if I go back 3, I'm up 7. Up 7. So plug in a minus 1 and see if the height is above or below my critical point. So to put negative 1 into f of x, I'll have f of negative 1 equals negative 1 squared for x squared. Plus 4 times x becomes 4 times negative 1, and then plus 10. So negative 1 squared, negative 1 times negative 1 is positive 1. 4 times negative 1 is negative 4. And then we have plus 10 on the end. Again, combine your positives, positive 1, positive 10, you're going to have positive 11. Positive 11 and negative 4, you're going to have 7, positive 7. So if I go back 1, that's up 7. And now the last step is to connect the dots. So the graph of the function x squared plus 4x plus 10 is going to come down, 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 flatten out at my critical point, come around, then go up, 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 up. And it'll go up forever on either end.